Okay, so today we'll be studying about solution of simultaneous differential equations using Laplace transforms. So first of all, you should know what is simultaneous differential equations. Suppose you have the equation of the kind, suppose you are given this question, solve dx by dt plus y is equal to 0, and the other equation is dy by dt minus x is equal to 0. So these are the simultaneous differential equations, and here what are the dependent variables? The dependent variable here is x and y, and the independent variable here is t. So this is the scenario here, because with respect to t we are differentiating and there are two variables and two equations. So we have to solve these two equations and calculate. For in the solution we are required to calculate the value of x as some function of t and the value of y as some other function of t. So this is what is required over here. So now they are saying solve this equation under the condition that x of 0 is equal to 1 and y of 0 is equal to 0. So this is required. Okay, so let us solve this. So for the solution, we will first consider this first equation, dx by dt plus y is equal to 0. Now if we assume that let the Laplace transform of x of t, that is equal to x bar, and the Laplace transform of y of t, that is equal to y bar. So if we assume this thing, then we know what would be the Laplace transform of the first derivative of x, that would be equal to s into x bar minus the value of x calculated at the point 0. Similarly, the value of Laplace transform of y dash t, that would be equal to s into y bar minus the value of y calculated at the point 0. So we can use this expression here. So firstly we'll apply Laplace transform on both sides. So we'll apply Laplace transform on both sides. So we have the Laplace transform of dx by dt plus the Laplace transform of y, that is equal to the Laplace transform of 0, and the Laplace transform of 0 is 0 only. So we'll substitute the values here. So this value is equivalent to this value. So we have s x bar minus x of 0 plus the Laplace transform of y, that is y bar, is equal to 0. And what is the value of x of 0 in the question? It is given to be 1. So we substituted here s x bar minus 1 plus y bar is equal to 0. So this is your equation number 1. Now we'll do the same thing with the other equation. The other equation was dy by dt plus minus x, that is equal to 0. So when you apply Laplace transform on it, it becomes the Laplace transform of dy upon dt minus the Laplace transform of x is equal to the Laplace transform of 0. Why? Because L is a linear operator, so you can separate out the terms here. And you know what is the Laplace transform of first derivative of y with respect to t? So s y bar minus y of 0, and the Laplace transform of x, that is x bar, that is equal to 0. Now what is the value of y of 0? That is given to be 0 here. So we'll substitute it, s y bar minus x bar is equal to 0. So this becomes our equation number 2. Now the next step is, what we have to do, we have to solve equation 1 and equation 2 for y bar and x bar. So that means you have to solve and calculate the value of y bar and x bar. So from equation 2, here you can see your x bar is equal to sy bar. So using the method of substitution, we can put x bar in equation number 1. So this becomes s into sy bar minus 1 plus y bar is equal to 0. So from here we can calculate what is your y bar. So we have s square y bar minus 1 plus y bar is equal to 0, or y bar multiplied by 1 plus s square is equal to 1, or your y bar, that is equal to 1 divided by 1 plus s square. So this is one value. Say this is your equation number 3. So we are substituting, put equation 3 in the value of x bar in equation 2. So from there we have x bar is equal to s times y bar. And what is y bar? Y bar is 1 divided by 1 plus s square. From here, from this expression, so we have the value of x bar as s divided by 1 plus s square. So this is equation number 4. Okay. So now the next step is, this is the value of x bar and this is the value of y bar. So now the next step is, next we'll apply inverse. So we'll apply the inverse Laplace transform on equation 3 and 4. So what do we have? We have Laplace inverse of x bar is equal to Laplace inverse of s divided by 1 plus s square. This is one equation, and another equation would then become, when you apply Laplace transform here, so it would be Laplace inverse of y bar, that is equal to Laplace inverse of 1 divided by 1 plus s square. So now this is very simple to solve, because we have considered the Laplace transform of x of t as x bar, so it would be x of t. So this is equal to, and according to formula, this is equal to cos of t, and according to this formula, y of t would be equal to sine of t, because you can write 1 to be 1 square and 1 to be 1 square. So that is why these are the answers. So this x is equal to cos t and y is equal to sine t, that gives you the answer. And these are the answer to the simultaneous differential equations, where we have solved these using the Laplace transform. So let us see another question. Question 2. This question says, solve the following equations using Laplace transform. So the first equation is 3 dx upon dt minus y is equal to 2t, and the second equation is dx upon dt plus dy upon dt minus y is equal to 0. And the conditions here are given to be x at the point 0 is given to be y at the point 0, that is equal to 0. So that means whenever t is equal to 0, both the dependent variables x and y, their values are also equal to 0. So this is what is given to us. So for the solution, we again follow the same steps. So first step is, we'll apply Laplace transform. We'll apply Laplace transform on both equations, on equation number 1 and 2. So suppose this is your equation 1 and this is your equation 2. So you'll apply Laplace transform. So you will have 3, the Laplace transform of dx upon dt minus the Laplace transform of y, that is equal to the Laplace transform of 2t. And in the second equation, you will have the Laplace transform of dx upon dt plus the Laplace transform of dy upon dt minus the Laplace transform of y, that is equal to 0. Now, because if you assume, let the Laplace transform of x of t, that is equal to x bar, and the Laplace transform of y of t is equal to y bar. So this implies the Laplace transform of dx upon dt is equal to s into y bar minus x of 0, and the Laplace transform of dy by dt, that is equal to s into y bar minus y of 0. So these are the formulas that we shall use here. Okay, so your equation now becomes 3 into sx bar minus x of 0 minus y bar, that is equal to 2 the Laplace transform of t. And what is the Laplace transform of t? It is equal to 1 by s square. So it is 2 by s square. So this is the first equation. And for the second equation, we have s into x bar minus x of 0. So this is according to first term, this term. And then we have, according to this term, s into y bar minus y of 0, and minus y bar is equal to 0. Now the initial conditions are given to be the term x of 0 here, and y of 0 here. They all are equal to 0. Therefore, we will have 3sx bar minus y bar is equal to 2 by s square, and sx bar plus sy bar minus y bar is equal to 0. So the next step is, so for the step number 2, we have to solve, this is equation 3 and this is equation 4. We have to solve 3 and 4. So how can we solve this? We can calculate the value of y bar from here and then substitute it here, whichever way you like. So what we can do, we can calculate from 3 the value of y bar. So it would be 3sx bar minus 2 by s square is equal to y bar, and we can put this value in, equation number 4. So we will have sx bar plus s minus 1 into y bar, and the value of y bar is 3sx bar minus 2 upon s square. This is equal to 0. So now we can simplify this and we can calculate the value of x bar from here. So let's do this. So this will be sx bar minus 3s minus 1 into x bar minus 2s minus 1 divided by s square is equal to 0. Or you can write this as x bar minus s minus 3s square plus 3s minus 2s minus 1s square, that is equal to 0. Or here, from here you have 2s minus 1 divided by s square into the factor, this one, s minus 3s square plus 3s. So from here you obtain the value of x bar. So next task is to calculate what is the value of y bar. So for the value of y bar, we'll substitute this value back into this particular equation. So that means you will have the value as 3s and the value of x bar, that is 2s minus 1 divided by s square, s minus 3s square plus 3s. So basically this becomes, so this expression becomes 4s minus 3s square. Okay, and this is the value of x bar. So we have 3sx bar minus 2 by s square, that is equal to y bar. So we can simplify this. this is our equation number 5, say. So we can simplify this. So it would be this s cancels with 1 power here. Okay, so we have 6s minus 1 divided by s square 4 minus 3s minus 2 by s square is equal to y bar, or y bar is equal to, we can take the LCM. Actually we won't take LCM. Why? Because we have to perform the inverse Laplace transform. So it would, we have to apply partial fractions over here. So it would be, when you apply partial fractions, so what do you have? Minus 2 by s square plus 6s divided by s square 4 minus 3s and minus 6 divided by s square 4 minus 3s. So now you have to solve this. So let's say this is your equation number 6. Now you have equation 5 and equation 6. So you will calculate in the third step, you will calculate the inverse Laplace transform of 5 and 6. So when you take the inverse Laplace transform of x bar, so that means you will have Laplace inverse of x bar, that is equal to Laplace inverse of, so that would be equal to Laplace inverse of the term two s minus 1 divided by s square 4s minus 3s square. And when you take the Laplace inverse of y term, so Laplace inverse of y bar, that would be equal to Laplace inverse of the term minus 2 by s square plus 6 by s 4 minus 3s, and then this is equal to minus 6 divided by s square 4 minus 3s. So that means after calculating the inverse Laplace transform, this term x bar, its answer would be 1 divided by s cube plus 2 by s square minus 1 divided by 2s s minus 2 by 3, and so the final answer here would be equal to, I'm sorry, here the final answer is not this one. So here the value would be x of t so it would be x of t, that is equal to t square by 2 plus t by 2 minus 3 by 4 e to the power 2t by 3 plus 3 by 4, and the final answer corresponding to y of t, that is equal to t plus 3 by 2 minus 3 by 2 e to the power 2t by 3. So these are the two expressions, and these are the values of xt and yt, these functions, which are the solution of the corresponding or simultaneous differential equations. So here you on solving these equations, what you have to do, you have to take the partial fractions and then apply the equivalent inverse Laplace transform formulas. So I hope this is clear to you all.